So I'm going to present quickly two models which we want to bring to this project. As you already said, it's the WISEE industry model on European level and the global steel model. So as a background, we call it the EDM, which stands for Energy Demand Model broadly. And this is a model family which has been developed at Wuppertal Institute over the last 10 to 15 years. You can see the model family in the figure below. So it's 8 different models currently, and they operate on different industrial subsectors, which are the bubbles on top. And below those sectors, there might be different processes or different, and they operate on different levels, be it Germany, which we have worked a lot on, or European level, or the world. So this is indicated by the colors of the bars. So we have worked a lot in Germany in the past, and the two things we want to bring to this project are rather new comparably. So we have the industry model and the European level. We have some sectors worked on for several years, but some of them since maybe 2 years only. And we have the global steel model, which is comparably very new. So we have just recently developed it, and it is now for the first time applied currently in the industry aspects project. So those models, we typically then combine and select them according to the targeted industrial subsectors and to the research questions and to the coverage. So what it does, broadly speaking, before going into the details of the two sub-models, so to say, the EDM is a tool. It helps us to analyze possible future industrial production systems and also to explore consistent pathways, how we get there. So it's a technological detailed bottom-up modeling tool. And the main objective typically is not to find some kind of optimal pathway, but it's more a tool that helps us to develop pathways that achieve a specific target, for example, net zero, and which are plausible in a broad range of viewpoints, so to say. So we take all kind of different data from existing roadmaps and scenarios, for example, on demand, to government targets, databases on all kind of stuff, technologies, for example, scientific literature, industry media, and so on. In particular, often we exchange with stakeholders from the industry, and we put this information in the EDM, often in a soft way, and the work with the model itself also depends on the different modules we choose. So I will talk on that later. And the main outcomes typically are CO2 in terms of emissions, and also in terms of stored or used CO2, and the energy demand and the feedstock use. We can also do some post-analysis on costs, on investments costs typically, or on relocation effects in the industry. How does it kind of shift its locations within Europe, for example? So typical research questions are, which technologies do we need for CO2 emission reduction targets in 2050? When do we need to phase them in to keep it in a typical reinvestment cycles? What energy do we need when and where? For example, which amount of hydrogen do we need in Duisburg when? And what do future production networks look like technologically and geographically? So can there also be some kind of redistribution of the production assets within Europe, for example? So a bit on the industry EU model first, or the models. So I've highlighted those which we typically use for this kind of analysis in the figure here, first focusing on the steel industry, the petrochemicals, and the refineries, which are those industry that we kind of have the deepest look at with the models. And mostly we use the three of the models in the order shown below. So we start, or can start, with a material stock and flow analysis, which is the EDMS, which shows in particular the amount of waste materials available for production. Then we have an optimization model, which is used to decide on investments, which considers all typical things. And maybe to highlight that in terms for the chemical industry, it also considers the pipeline network between industrial sites. so for feedstock and for intermediate products, so that the transport costs can be assessed there. And then this goes into the EDMD, which is a kind of dispatch model, which calculates actually the CO2 and the energy demand. Some things to highlight maybe there's that we do a site or network-based balancing of industrial byproducts. So for example, hydrogen, if it's produced in one process and it's needed in another process in the same hydrogen network, then this is kind of balanced before the demand is given to the output. So much maybe for those sectors. So yes, we do it, we model the physical production and we have it a detailed representation of the sites and the processes for EU 27 plus UK. So here we can do a subnational analysis for those sectors best. For the other industry sectors, the modeling is more simple. So we have the other energy-intensive industry, starting from cement, lime, glass, non-ferrous metals, and so on, which we do model also on a physical basis, but activity-based at the country level. So here we don't currently have an explicit representation of capacities. While we do know the plans for cement, for example, we don't have it explicitly in the model yet. And then we have different sector-specific mitigation options and strategies that can be applied here. For the non-energy intensive industry, we do it non-physical, but an economics-based extrapolation of the energy demands, applying things like efficiency parameters and technology shifts and so on. So this is a quick view on typical exemplary outputs, which you might expect. On the right-hand side, for example, you can see greenhouse gas emissions, final energy demand. We also have the feedstock, which is not pictured there, but this is like how our typical output currently looks like, 5-year steps. Yes, and then below you can see an example for a shift in production route here for the steel industry, for example. That's also a very typical kind of output we have. So how does steel production change over time? We can also, as said before, analyze investment costs or geographical aspects. What we have not done yet is to have a specific links to SDGs. So I think you can make up some links to greenhouse gas reduction and so on, but we haven't explicitly done so in the past.